Going live. And we are now live. And this is the TWIS Minion Science Island Hangout. And joining me is Dale. Dale from Canada. And he will be eating as we're moving on through the hangout. Jani from way over in Iceland. Where they have actual reindeer. They have actual, you know, Santa's got real live reindeer out there.
Ed, he's in Finland.
Finland. I said Iceland. Ah, well, that's close.
Not really. It's across the border.
And we have Patrick from his little work area. What do you call it? The hack area? The something or other area?
Hackerspace. Hackerspace. Kind of an innovation lab. Not really quite yet.
With a disembodied voice out in the distance from a guy named Chris. How are you doing?
Yep. He's afraid of cameras, apparently.
Afraid of cameras. All right. And I'm Ed from Connecticut, and I'm not afraid of anything. I'm not afraid of making a fool of myself. So
I don't want to be on TV unless I'm on TV.
You're not on TV. You're on the internet.
Well, I don't want to be on the internet unless I'm on the
TV? TV doesn't exist anymore. Jeez, that's old school. Come on. TV. Let's see. What do we got? We got some stories about a wireless brain sensor. And we got a interesting story about how lethal control, which means killing wolves, is not helping the livestock at all. We got a 3D printer. I like this one because it talks about frail senior citizens. Well, I'm a senior citizen. Hopefully I'm not frail. But someday we can have that replicator. That's all a 3D printer is, a replicator. I can 3D print my food. And we got a story about superconductivity, and the lead story and topic talking about tinkering with the climate and what kind of parameters we should try and establish. And a few other stories, and I'm going to leap into the first one, which is talking about a wireless brain sensor. And actually there's a picture of it, if I can find it. Let's see. I always have problems with the screen sharing business. Let me see. Okay.
So are we starting off with the geoengineering one, or?
Yes, we are. Yes, I am.
Chris brought up a really excellent point.
All right.
Chris.
My only concern, and it's mostly a word choice issue. I'm kind of nitpicky with the whole word choice when it comes to geoengineering and making good decisions versus bad decisions. And I'm willing to admit there's maybe an American bias to this statement, realizing this is an international audience. But my concern with bad geoengineering, if it's bad, what is the difference between bad geoengineering and pollution?
Good point.
Well, first you start with the bad engineering, which leads to the pollution. And then you go on, hopefully, to the good engineering. It gets rid of the pollution and does something else terrible, probably.
Geoengineering is...
That's a catch-all phrase.
Yeah, no, but geoengineering is engineering with good intent.
You cannot ascribe moral intent to engineering.
Why not?
Because it's independent of the user. Engineering.
Well, if the engineer had good intent designing it.
That good intent almost is irrelevant given history.
Yeah.
Well, come on, guys. Can you see this picture? This real cool.
I'm not quite sure what it is.
Yeah, this is engineered. This is a brain sensor. How about that? A brain sensor. We got neuroscience research has been constrained by the cables required to connect brain sensors to computers for analysis. And a bunch of Brown University researchers have a wireless brain sensing system to acquire high-fidelity neural data during animal behavior. There we go. Masters and Johnson. I want the sex study thing. In any event, the scientists, they described a new high data rate, low power, wireless brain sensor. This technology is designed to enable neuroscience research that cannot be accomplished with current sensors that tether subjects to a cable connection. And this experiments in the paper confirm the new capability, and the results show that technology transmitted rich, neuroscientifically meaningful signals from animal models as they slept and woke or exercised. We view this as a platform device for tapping into the richness of electronic signals from the brain among animal models where their neural circuit activity reflects internally viotational, can't pronounce it, don't know what the word means, and neuralistic behavior not constrained to particular space. This enables new types of neuroscience experiments with vast amounts of brain data wirelessly and continuously streamed from brain microcircuits. Okay, I'm going to stop there. What are they talking about? It's VOLITIONAL and neuralistic behavior.
Where is that?
It's the fourth paragraph down. Reflects entirely VOLITIONAL. Neuralistic, that I can get, but I don't know what that first word means.
Neuroelectronic. Is that the one you're looking at? Neuroelectronic?
Excuse me? I'm looking at the first story, story number 1. The paragraph that begins with, we're really together here tonight. I can see that.
I just lost where you were reading, and I'm just trying to catch up as to...
Neuroelectronic.
I will move on. We can discuss this back later. The custom-engineered neuroelectronic platform is composed of 2 elements. A 100-channel transmitter, only 5 centimeters in the largest dimension, and weighing only 46.1 grams. And a 4-antenna receiver that looks like a home Wi-Fi router, but employs sophisticated signal processing to maximize the transmitter signal while the subject is moving around. Now this part's not so good. Via a small port embedded in the subject's brain, the transmitter connects to a tiny implanted electrode array that detects the activity of scores of neurons in the cortex. The transmitter wirelessly, the wireless transmitter is compatible with multiple types of classes of brain sensors, the researcher says. Now, everything was looking fine, and they talked about embedding something in the subject's skull. Among the unique features of our technology is that we developed this compact, lightweight neurosensor with a custom-designed, low-power, high-efficiency transmitter. It dissipates 2 magnitudes less power than a commercial 802.11 transceiver to broadcast a comparable rate of high-speed data up to 200 megabytes per second within a few meters distance. The low power and small size, along with the built-in electrostatic discharge protection features, make our device safer and more practical for mobile use. And they did a couple of experiments. In one experiment, 3 rhesus macaques took walks on a treadmill where the researchers used a wireless system to measure neural signals associated with the brain's motion commands. Meanwhile, they used other sensors to measure the activity of leg muscles. The data from the brain showed clear patterns of activity related to the movements of the signals, demonstrating that the signals allows for studies of how the brain controls the legs. In this study, we were able to observe motor cortical dynamics during locomotion, yielding insight into how the brain computes output commands sent to the legs to control walking. In another experiment, the researchers used the technology to observe brain signals for hours on end as the animal subjects went through sleep-wake cycles, unencumbered by cables or wires, but with something embedded in their brain. Again, the data showed distinct patterns related to the different signals of consciousness and the transitions between. He says, we hope that the wireless neurosensor will change the conical patagram, I butchered that one, of neuroscience research, enabling scientists to explore the nervous system with its natural context and without the use of tethering cables. Real cool device. Not so sure about the implanting of a device into the brain, however. I'm not going to sign up for that one.
I don't get why it's, I don't know. I'm not that impressed. Like, what's it actually measuring? What kind of science are they doing? It's, as far as I can tell, there's electrodes. There doesn't appear to be anything novel about them. They've attached it to a sensor that basically uses Wi-Fi to transmit the data around and could potentially affect your data, right? If the transmitter is strong enough.
Well, what they say they're eliminating is the cable connecting the subject to the device, to whatever device is reading the signals. So what they're doing here, they say, is they're getting rid of the cable, and they're replacing the cable, which is tethering the subject to the sensor. They're eliminating the cable, and they're implanting a device into the subject's skull, and that is what is doing the transmitting. And it's transmitting from there to the device that's monitoring the activity.
Huh. Well, interesting. So the big thing is the Wi-Fi router on your head.
Yeah. Yep. Yep.
Huh. Sorry, I don't get it. I
don't want it if they're talking about implanting something in my brain, that's for sure.
But I don't get the, what's wrong with external electrodes that are more sensitive?
Well, I guess it would be, I guess the idea would be you could have your subject doing something a ways from where the recording device is, the device that's recording what's happening in your brain. So you could have you had these little monkeys on treadmills. Man, that sounds like fun.
So I think it's more or less you'll probably get different results if it's in a lab setting as opposed to like a natural setting. And therefore you can't really have wires in a natural setting if you want to get accurate results of what's actually happening. Mind you, lab settings get rid of a bunch of variables, but at some point you want to see what happens in the actual environment. And so I think that gets this in that direction.
I thought like electrodes are really, they measure very general trends, as far as I know. And the science that you can do with it is, with electrodes, is very general. So anyway, yeah, I don't know.
That's it. The main thing I see is that you just talk about removing cables without the tethering cables.
So attaching data to a Wi-Fi router.
That's it. Yeah, that's exactly it.
Yeah.
All right. This next story talks about how lethal controls of wolves. The idea being that the nasty wolves are killing your livestock, and if you kill off the wolves, you're going to help livestock production. And these researchers have they come up with a study which proves the opposite is true. And the researchers have found it is counterproductive to kill wolves to keep them from preying on livestock. Shooting and trapping led to more dead sheep and cattle the following year, not fewer. Wildlife biologists said that for each wolf killed, the odds of more livestock predation increased significantly. And this is wildlife biologists Rob Weiglis and Kyle Pebbles. The trend continues until 25% of the wolves are killed in an area. Research and wildlife managers then see what they say is a standing wave of livestock predation. Moreover, the rate of wolf mortality is unsustainable and cannot be carried out indefinitely if federal relisting of wolves is not to be avoided. The gray wolf was federally listed as endangered in 1974. During much of the recovery in the northern Rocky Mountains, government predator control efforts have been used to keep wolves from attacking sheep and livestock. With the wolves delisted in 2012, sports hunting has also been used. I don't mind hunting. I'm all for hunting. But sport hunting, no. Not for sport hunting. But until now, the effectiveness of lethal control has been what Weiglis and Pebbles called widely accepted but untested hypothesis. Our study is the largest of its kind, analyzing 25 years of lethal control data from U.S. Fish and Wildlife Services interagency animal wolf reports in Montana, Wyoming, and Idaho. They found that killing one wolf increases the odds of predation 4% for sheep and 5 to 6% for cattle the following year. If 20 wolves are killed, livestock deaths doubled.
Okay.
They didn't expect to see this results. I had no idea what the results were going to be, positive or negative. Let's look at what it is and see what is happening. So let's do a study. Let's use the science to find out what the actual effect is. Weiglis said, the wolf killings likely disrupt the social cohesiveness of the pack. With an intact breeding pair, will keep young offspring from mating, and disruption can set sexually mature wolves free to breed, leading to an increase in breeding pairs. As they have pups, they become bound to one place and can't hunt deer and elk as freely, and then occasionally they hunt livestock. Under Washington's state wildlife management programs, wolves will be protected species until there are 15 breeding pairs for 3 years. Depredation and lethal controls, legal and otherwise, are one of the biggest hurdles to that happening. Wolves from the Huckleberry Pack killed more than 20 sheep in Stevenson County, Washington this summer, prompting state wildlife officials to authorize killing up to 4 wolves. An aerial gunner ended up killing the pack's alpha female. A second alpha female from the Tenaway Pack near Ellensburg, Washington, was legally shot and killed. That left 3 breeding pairs in the state. As it is, a small percentage of livestock deaths are from wolves. According to the management plan, they accounted for between 0.01% and 0.06% of all livestock deaths, a minor threat compared to other predators, disease, accidents, and dangers of calving. In the ongoing study of non-lethal wildlife control, the large carnivore lab this summer monitored 30 radio-tagged sheep and cattle in eastern Washington, Wolf County. None were killed by wolves. Still, there is some predation. He encourages more non-lethal interventions like guard dogs, range riders on horsebacks, flags, spotlights, and risk maps that discourage grazing animals in hard-to-protect wolf-reach areas. When I posted this story on Facebook, Charlie Hahn made a very good point. He said if people keep killing wolves, he expects they'll just wind up with the eastern coyotes colonizing backwards to the west. And coyotes are a lot harder to control, to kill, than wolves.
No, it's a good study. That's another lesson in things aren't as easy as they seem from the outside. You look at a predator like a wolf, and you make certain assumptions, and sometimes our assumptions don't lead us into the right direction. So you have to do some hard, well laid out planning and some science to figure out exactly what's going on. And hopefully that this does it. Looks like some. So they looked at several years, 25 years of data.
Mm-hmm.
So, you know, as long as that data is fairly accurate, they may have found their answer.
And as part of one of the study where they tagged 300 sheep and monitored 300 sheep, I'm going to find out. Now, if you ask a rancher or a farmer, they'll probably say, okay, they're expecting at least one wolf kill. And it hasn't happened yet. And again, it's, you know, base your decisions on science, on scientific studies.
Yeah.
And what happens, I mean, you eliminate an apex predator like a wolf, it's going to be replaced by something. You replace that wolf with a coyote that has no fear of people, that's going to start killing, you know, your sheep, etc., a lot closer to home. Heck, a coyote will probably go right into the corral, and they're, you know, they're a lot harder to control, and you'll probably see a lot more animal predation if you replace the coyote or the wolf with a coyote.
Yeah, for sure. And that was all. Was it all done in Washington State?
Montana, Washington, and I forget the third. Utah, maybe. I forget the third state.
Okay.
Yeah. And you know, these programs, these killing of predator programs, are really generally get politically motivated. You know, your ranchers, your farmers, you know, they see a kill and they say it must be a wolf kill. More often than not, you get a biologist looking at it and say, no, that's not a wolf kill, it's something else.
So I guess part of the question is, do people believe the science, right?
Yes, that is exactly right. Well, that's where, you know, if you can look at it and say, okay, we have these sheep, we're monitoring these sheep somehow, and then, you know, hopefully after a couple of years, 3, 4, 5 years worth of data, maybe you'll get one kill or something, and you'll be able to prove. That will certainly prove it, I would think, to your farmers, to your livestock breeders. All right.
Yeah, that's a good study.
Oh, sorry. Go ahead.
I was just saying that's a really good study.
Yes, it is. This next story, and this story talks about 3D printing food. And it talks about frail old seniors. Well, I'm a senior, but hopefully I'm certainly not frail. But I did actually see this with my stepmother. Now, my stepmother lived to be 93. But maybe the last 10 years, 5 to 10 years, I had to take care of her. And it was really hard to get her to eat enough nutritional food. And I think certainly that inability, the last 5 years of her life were not good. Were not good.
That's not encouraging.
The researchers are now developing personalized food for elderly people with chewing or swallowing problems by working on printable versions of meat and vegetables. How cool is that? Printable versions of meat and vegetables. In Europe, the population is aging. In 2010, about 17% of the population were 65 or older. This number is projected to increase to 30% of the population by 2060. Heck, I'd say a lot more. I'm going to say that, oh, that's percentage of the population, though. Certainly people we're going to be living into our hundreds, and hopefully we'll be taking better care of ourselves. So that that population of us who are in healthcare facilities will decrease. New services are all of it already available to meet their needs. This range of technologies enabled elderly people to live independently to medications or even diets adapted to this age group. As part of this is a European-funded project called Performance, due to be completed by 2015. A research consortium is now developing an industrial process for producing personalized food for frail and elderly people to improve their quality of life. The trouble is that this percentage of old people are susceptible to malnutrition. And it's particularly true for those having problems chewing or swallowing. In nursing homes, about 1/5 of the residents need a special diet. This is the project coordinator, is the CEO of a company called Biozoom. These people often receive unattractive porridge-like food 7 days a week, and that's what my stepmother would eat 7 days a week, oatmeal. These people often receive unattractive porridge-like food for 7 days a week, but meals are socially important for elderly people. The project partners therefore want to prepare food in such a way that these people are able to eat safely and even enjoy their meals. A number of residential homes for the elderly in Germany already apply the so-called smooth food concept. Large industrial food producers, mainly using eggs or starches, to solidify their strange food. But this food all tastes the same. To keep the food tasty and visually appealing, the researchers apply a heat-stable, plant-based solidifying agent. The chef can reshape this smooth food with the help of silicone molds. However, this approach is not suitable to large canteens or catering services. We therefore apply 3D printing technology to industrialize the manufacturing process. And let's not talk about, what is it, Soylent Green. Let's not talk about that. 3D printing offers various advantages, according to these people. Printing the food layer by layer offers creating various forms. Moreover, the manufacturers can enrich the meals with proteins, vitamins, and other minerals. Thus, we can personalize the food, for example, in terms of caloric content or serving size, to avoid malnutrition. Currently, the project researchers are trying to find out how to make different types of food, such as meat or vegetables, printable. A prototype of the food printer should be available by 2015. There will also be studies in 2 of the nursing homes to testify whether elderly people find such foods more acceptable. An expert agrees that the growing number of frail people need a specialized diet. The issue of nutrition is critical, and malnutrition is a large problem. And even in a country like the United States, where you don't expect to see malnutrition, but you're seeing it in a lot of elderly people because the way food is being delivered, not getting the right nutrition, not getting the right amount of vitamins, and getting the people to eat it. They can supply the food, but like my stepmother, she wouldn't eat it. You would make a regular meal, she wouldn't eat it. An expert agrees that the growing number. Oops, where are we? An expert agrees that the growing number of frail people needs a special diet. And this is Giovanni Larimore, a researcher with the National Health Institute of Aging in Ancona, Italy. He considers the project's approach as useful as far as specialized food products for residential neighbors or home care services are concerned. He regards 3D printing as an advancement that can help reduce cost. And specialize. Well, this project is designed to meet the needs of large numbers of people, so that you can 3D print this food so it looks attractive, contains all the right nutrients. And I think even on a smaller scale, where you can get the right nutrients into the food. So if you're taking care of an elderly relative, maybe you can experiment, and maybe you can, you got to get the material, foodstuff itself. But if you can 3D print it, I don't know, make it colorful designs, find the right, maybe the person likes a particular kind of food. Well, my stepmother was oatmeal, but maybe you can make it more attractive for them. 3D printed food. What do you think, Dale?
I think that I think swallowing is really important, and I'm not kidding. Plenty of elderly lose the ability to swallow, and if you have to turn to a feeding tube, that's a huge problem. That's a really, really big problem. And so if you can extend that period of time through this 3D printer, where you can actually customize their food to make it not only more attractive, but easier to ingest for the different types of conditions that are out there. It's a big deal. Now, I have trouble with this one. I think they're going to run into a lot of difficulty. I don't, it's good that they're trying, but I would guess we're not going to hear about this one again, not for a while. Printing it out and having it so that someone wants to actually eat it, and then at what cost? I think it's admirable that they're trying it and they're going after it. Maybe they will hit the jackpot with it, but this sounds like a much more difficult thing to do than it appears from the outside.
I agree with you. Cost is going to be a factor. 3D printing of food in the future. This is a first step. This kind of technology could be a first step. You think about in a place where you can't raise, the animals themselves. I don't know, maybe even in a, maybe when you're in space or on Mars, and it's difficult to change the environment. But what you can do, if you can get the chemicals that make up the food, and then you can, using a 3D printer, layer it and maybe manipulate it and maybe add some coloring, so at least psychologically it looks like the food, good food. And then instead of, like, we use a blender now to mix different foods together, this would become in effect like a 3D blender, and you could experiment with it. When the food products themselves, you don't have a supermarket nearby where you can just go out and get the products. So it has some potential for the future.
Yeah, for sure. And there's lots of research going on around that area, growing meat and all sorts of things. Organic chemistry.
Dr. Kiki had a food science series where she was explaining the chemistry behind food.
Oh, that's
interesting. Cooking through better chemistry. All right, Dale, you want to cover this next story about superconductivity?
I'd love to. So rattled atoms mimic high-temperature superconductivity. So X-ray laser experiment provides first look at changes in atomic structure that support superconductivity. An experiment in the Department of Energy's SLAC National Accelerator Laboratory provided the first fleeting glimpse of the atomic structure of material as it entered a state resembling room temperature superconductivity, a long-sought phenomena in which materials might conduct electricity with 100% efficiency under everyday conditions. That's a huge deal if they ever reach that in a way that can be reproduced inexpensively. That's really big. So researchers used a specific wavelength of laser light to rattle the atomic structure of a material called yttrium, yttrium barium copper oxide, or YbCO. They then probed the resulting changes in the structure with an X-ray laser beam from the LINA Coherent Light Source, a DOE Office of Science user facility. They discovered that the initial exposure to laser light triggered specific shifts in copper and oxygen atoms that squeezed and stretched the distances between them, creating a temporary alignment that exhibited signs of superconductivity for a few trillionths of a second at well above room temperature, up to 60 degrees Celsius or 140 degrees Fahrenheit. The scientists coupled data from the experiment to theory to show how these changes in atomic positions allow a transfer of electrons that drives the superconductivity. So new views of the atoms in motion. This is a highly interesting state, even though it only exists for a short period of time. This is one of the dudes from the Max Planck Institute. And it was published in Nature, I guess. So when the laser excites the material, it shifts the atoms and changes the structure. We hope these results will ultimately help in the design of new materials to enhance superconductivity. Sustaining such a state at room temperature would revolutionize many fields, making the electrical grid more efficient, enabling more powerful and compact computers. Traditional superconductors operate only at temperatures close to absolute zero. YBCO is one of a handful of materials discovered since 1986 that superconduct at somewhat higher temperatures, but they still have to be chilled to at least minus 135 degrees Celsius in order to sustain superconductivity. And scientists still don't know what allow these so-called high-temperature superconductors to carry electricity with zero resistance. So a powerful tool for exploring superconductivity. Josh Turner, a SLAC staff scientist, that's funny. Josh Turner, a SLAC staff scientist, who has led other studies of YBCO at the LCLS, said powerful tools such as X-ray lasers have excited new interest in superconductor research by allowing researchers to isolate a specific property that they want to learn about. This is important because high-temperature superconductors can exhibit a tangle of magnetic, electronic, and structural properties that may compete or cooperate as the material moves toward a superconducting state. For example, another recently published LCLS study found that exciting YBCO with the same optical laser light disrupts an electronic order that competes with superconductivity. What LCLS is now showing us is how these different properties change over short times. We can actually see how the electrons or atoms are moving. Mankowski said future experiments at LCLS could try to sustain the superconducting state for longer periods and use a combination of experimental techniques to study how other properties evolve in the transition into the superconducting state and explore whether the same structural changes are at work in other high-temperature superconductors. And it just goes on to say the researchers where they're from. So that's interesting. I think we still got to keep researching superconductivity at room temperature. But you know, although they had this, you know, it's amazing they had superconductivity even for that extremely short period of time.
The technology involved, where you can measure something in trillionths of a second, and you know, the material that you're dealing with, like individual atoms.
Yeah, I wonder if what they're doing is like it's a specific wavelength of laser light, and I wonder if that has to do with the matching component to the atom, and you know, much like RF works, where you try to get the closest match you can to an antenna, so that you have a high efficiency state on either receiving or transmitting radio frequency energy. So yeah, it's interesting. Like, you need to keep working on this, but kind of unimpressive too.
Long way to go.
Long way to go, and you know, you've got these people doing this really, really hard science, and this is how we eventually hit breakthroughs. But boy, being a scientist and struggling through these, you know, you got to celebrate the strong winds when you're seeing like these tiny little states that occur, that superconductivity. And they said, what, trillionths? Or
Yeah, trillionths of a second.
yeah, so it's amazing that you have the equipment to be able to measure that and see it.
Yeah, you talk about room temperature superconductivity. That's a very, very long way off having a device that can utilize that. It should. I mean, you're talking about even degrees. Where do they start with? Minus chill to minus 135 degrees Celsius, and that was just a starting point. Couldn't do anything till they chilled this material to minus 135 degrees Celsius.
Yeah, that's as close as they can get. Right?
But it's a start. It gives other researchers something to look at, something to consider.
Yep. Yeah, somebody has to do that really difficult, hard science where it's kind of thankless, and but it does need to be funded, and somebody does need to work on it.
Like the quantum computers that we talk about a lot, you have to get the temperature, when you're building the device, what do they call it? Jesus, I can't think of it. The chips, computer chips. I mean, you still have to do that working at temperatures very, very cool, and in a particular kind of chamber. Even D-Wave uses a very he uses a chamber where temperatures are cooled down extremely low just to build the chips.
Yeah, you're basically when you remove heat, you're removing energy, and so the atomic structure they vibrate less and less and less and less as they cool them down, and eventually they get to a state where things become measurable, where you can actually manipulate matter and in its atomic state.
Going to move on to perhaps the lead story, talking about geoengineering, and I'm going to start. Well, I'll start with how Wikipedia breaks down geoengineering, just to give you some definitions, a starting point. And Wikipedia breaks it down into climate engineering, environmental engineering, and planetary engineering. Now, planetary engineering, I'm not planning to talk about, but perhaps Patrick and his friends do, because now you're talking about terraforming planets. But first, environmental engineering is something we are doing already in some cases. Climate engineering, not much. And well, climate engineering, according to Wikipedia, is the deliberate and large-scale intervention in the Earth's climate system with the aim of reducing global warming. Climate engineering has two categories of technologies: carbon dioxide removal and solar radiation management. Carbon dioxide removal addresses a cause of climate change by removing one of the greenhouse gases from the atmosphere. Solar radiation management attempts to offset effects of greenhouse gases by causing the Earth to absorb less solar energy. Geoengineering has been proposed as a third potential option for tackling global warming alongside mitigation and adaptation. Scientists do not typically suggest geoengineering the climate as an alternative to emissions control, but rather an accompanying strategy. I'll jump ahead a bit. No known large-scale climate engineering projects have taken place to date. Almost all research has consisted of computer modeling or laboratory tests, and attempts to move to real-world experimentation have proved to be controversial. Some limited tree planting and roof projects are already underway, and ocean iron fertilization has been given some small-scale research. Not lots and lots of controversy. A couple of people have tried it, and their efforts were stopped. Environmental engineering is the integration of science and engineering principles to improve the natural environment, to provide healthy water, air, and land for human habitation and other organisms, to clean up pollution sites. Environmental engineering can also be described as a branch of applied sciences and technology that addresses the issues of energy preservation, production, assist, and control of waste from human and animal activities. Furthermore, it is concerned with finding plausible solutions in the field of public health, such as waterborne diseases, implementing laws which promote adequate waste management and air pollution control. Skip ahead a little bit. Environmental engineers study the effect of technology's advances on the environment. To do so, they conduct hazard waste management studies to evaluate the significance of waste hazards, advice on treatment and containment, and develop regulation to prevent mishaps. That's a little bit of a background. And what's taking place is, what has taken place on December 1st, the United Nations kicked off a summit in Lima, Peru, that aims to forge a global deal to reduce greenhouse gas emissions. Good luck with that. Now, representatives of dozens of scientific societies are gathering in Washington, D.C. to thrash out a set of principles for researching highly controversial technologies known as geoengineering. The methods are for ways to cool the planet should political approaches fail, which they will. And the bottom line here is, how do you come up with field trials? You know, right now we have a lot of computer modeling. You can do things in the laboratory, but you got to be very, very careful when it comes to coming up with field trials. There are a number of risks and unknowns. And this is Paul Birchos, I can't pronounce his name, Director of Land and Water Flagship at the Commonwealth Scientific and Industrial Research Organization in Brisbane, Australia. He was a past chair of the Council of Scientific Society Presidents. We urgently need to develop and implement a coordinated research plan that begins to address these issues in a deliberate way. Some ideas, such as injecting carbon dioxide into rocks or the depths of the ocean, are already being tested. Others are more futuristic, spraying seawater into the air to brighten clouds and reflect more sunlight back into space, adding sulfite particles to the upper atmosphere to mimic the natural cooling effect of volcanic ash, and even placing giant mirrors into orbit to reflect sunlight into before it reaches Earth. No one, however, has garnered much enthusiasm in environmental or political spheres. And the idea of tinkering with planets smacks of scientific hubris, and many are worried about unintended consequences. Climate scientists are concerned, for example, that adding sulfate to the stratosphere might reduce rainfall in some regions and worsen ozone depletion. So between March 2nd and 3rd, leaders of societies representing some 1.4 million scientists, engineers, and educators will work out what research is and not acceptable given the possible social, ecological, and economic effects of climate engineering. A previous conference in 2010 in California failed to produce guidelines. Most scientists say that it's far too early to consider large-scale trials, especially for solar radiation management, because the technologies have not yet been adequately tested in controlled settings. How the heck do you come up with controlled settings? However, many maintain that geoengineering should not be ruled out as a last resort to prevent the worst effects of global warming. And I'm going to say here the political attempts to control carbon dioxide emissions, not going to work. There are projects happening in the non-political arena which show some promise, but overall, I don't think the politicians anywhere, United States, China, anywhere, really, I'll say, have the backbone to do anything meaningful. So really, geoengineering might come down to a last resort. And it's possible we could, 30, 40, 50 years from today, might find ourselves in a position where we have to try something. The question is if and when we should start doing outdoor experiments. And this is Matthew Watson, a volcanologist at the University of Bristol in the UK, who is overseeing a project to determine how the deliberate spreading of sunlight-blocking particles might alter atmospheric chemistry. I don't particularly like geoengineering, but I'm afraid we need to think about controlled field studies. A method that has already been tested, ocean fertilization, provides a particularly thorny case study. The idea was to boost ocean uptake of carbon dioxide by pouring iron into the sea to stimulate the growth of algae blooms. When the algae die, the captured carbon sinks to the ocean floor, where it may remain locked away for centuries. But the approach came under fire when eco-entrepreneurs smelled business opportunities. Plans by companies in the United States and Australia to fertilize large swaths of ocean to generate carbon credits that could be sold on greenhouse emission markets were headed off by a 2008 amendment to the London Convention that governs ocean pollution. Together with a resolution made under the United Nations Convention on Biological Diversity a few months later, the amendment made it difficult to conduct trials of ocean fertilization. In 2009, an international research cruise ship was stopped en route to the Southern Ocean where fears that an iron simulation algae bloom the team had planned to encourage might violate international law. Another attempt by an amateur scientist in 2012 off the coast of British Columbia led an international storm of protest and prompted heated discussion in the Canadian government over the legality of the experiment. Such unresolved governance issues mean that little funding is available for future studies. We're caught up in politics, says Kenneth Buesler from Woods Hole Oceanographic Institute in Massachusetts. We'd absolutely like to avoid rogue experiments that don't generate proper science, but there is every reason to pursue real science in the field and an open and responsible way. And I'll stop there. That's the conundrum.
Well, it's like pick your poison. Stop polluting now. Invest a huge amount of money right now. Try to geoengineer later when people start to panic and it's too late. It's all pick your poison. Which one do you want to swallow? And none of it's good, but we all got here together. So I think that I'm not definite about this. When they do their climate predictions, do they take into account like clean technologies that will that are exponential, like solar panels? Do they account for that in their future forecasts of carbon particulate in the atmosphere? So many parts per million. Do they account for the trend that solar is following and where we'll be in 30 years and how much less dirty energy is going to be out there?
I think they do track that.
Do that?
And there are certain agencies tracking that. I think overall it's such a minuscule. What is it? I don't know, Patrick, we talked about this a couple of weeks ago. Less than 3% total, maybe a 0.03% in terms of total energy.
There was actually just an article released by a couple of Google engineers who said that, and their project was to look into alternative energies and whatnot and what have you. And they said renewables aren't the answer because the amount of energy we would have to produce to create the renewables in the first place would offset any of the benefits for like decades or something. And that nuclear is really the only way to go.
Yeah. I mean, there seems to be a consensus, at least within the scientific community, that we typically got to start building nuclear power plants.
Yeah.
We don't have a good alternative. I don't know how many nuclear power plants are in the stage of construction. I've read about some states like Iowa investing in it. I don't know if they're actually building them. Now, how long does it take to build? What's the window? 5 years, maybe?
No, it's like 15.
Oh, 15 years. Uh-oh.
There's a lot of regulatory stuff that's got to go through.
Well,
this is why no one's trying to build anything, because it takes so freaking long.
15.
I think to build like a coal power plant, it takes like 3 years or something, but to build a nuclear plant, it's like much, much more than that. Let's see here. Let's find out.
You're not going to get people with buckets of money to invest in something that's not going to pay off for 15 years or more.
Well, Bill Gates did. Oh, it takes 5 to 7 years to build a nuclear power unit, not including the time required for planning and licensing. So more than 7 years.
Yeah.
I bet you might be right. By the time all the planning's done, I bet you it's 12 to 15 years.
Yeah.
So even from the point where if we ever decide in the United States to commit to it, and we start the process, you're still looking 15 years at least out.
Yep. Yeah, it's not good. And have to do something.
Yeah. I think, I don't remember, there was one chart I saw.
It takes 4 years to build a coal power plant and 3 years to build a gas power plant.
I think when it comes to, I think it was new resources, new resources, as of 2013 or 14, I think solar was like maybe 20%. It was gaining among the new resources people are using, but fracking was still far and away, I don't know, like 50%. And I don't see any signs that there's going to be regulations or any initiatives by the American government to reduce fracking or control fracking. I think that's going to continue to be the preferred method. And natural gas is used for home heating mostly.
There are natural gas power plants.
I know. Well, we had a very cold winter, and because of the amount of fuel oil we used, I'm getting hit with a $330 extra charge to my year. That's one-time charge to my common charges because of all the fuel oil we used last year. And Connecticut Light and Power, they had a 6% increase in October. They want another, I think it's 16% increase in January. So my electric bill would go up, I mean, something like 20% in really only a short period of time. And the company itself, CLMP, they're kind of claiming that, okay, we got to do more fracking. We got to get that, what is it, that big project, the, I can't think of the word, the Koch brothers, that pipeline they want to build. And I'm going to guess that pipeline's going to get built. Maybe you'll have it stopped in the courts by some ecological environmentalist or something, but I'm not sure that Obama's going to block it. It's funding for it or approval for it is going to pass in Congress. That's absolute. The only question is Obama going to block it, and I'm not sure that he will. So, fracking is in our future.
Unfortunately.
I'd like to see that Google study because I have trouble thinking that creating a solar panel would offset the reduction by a 10+ year period. I have trouble with that.
I'd have to find the article to give you the actual numbers. But they were like, yeah, renewables aren't the answer.
What about
you're not gonna do it?
A hope is
actually, come to think of it, Jani, did I see that in your feed? Did you post that article? It would have been on like engineering, extreme engineering, or something like this. I can't remember what it's called. I might be able to find it in my feed. I think I commented on it.
If you can
I think solar will make a much larger impact. I think we're underestimating it.
If we can build that better battery so that we can store the solar energy for longer periods of time, certainly at least overnight, and so you got a car, that electric car that you can run. And it's $25,000 to $30,000, and you got a charging station just as close as a gas station. When you reach that point, that's one thing, something that will help. Everybody will start driving electric cars, I think.
Yeah.
I don't know. But how do you conduct a field study when you're talking something like the climate? You can do a lot of lab work and stuff, but how do you conduct a field study? You can't. I don't know how you section off a part of the sky, the atmosphere, so that whatever you're doing doesn't expand beyond that area.
Yeah, I think I think Craig Venter is working on some stuff too with bacteria that will remove carbon out of the atmosphere and use it to produce fuel. That may be the answer too, is organic chemistry and synthetic biology. That may be part of the answer too.
Mm-hmm. Technology will have to be the answer one way or another. And so Patrick has posted this in the chat area.
IEEE.
Let's see, reading it. Producer's goal was to produce a gigawatt of renewable power more cheaply than a coal-fired plant in years. Let's see, there's the chart.
This one's a rather long article. There's a really short article on Fox News.
I'm wondering how he came to this conclusion.
After lots of research. I mean, you'd have to read the entire article. The entire article is like 4 or 5 pages long.
Yeah.
I'm trying to find a good quote.
And this is, of course, this is one guy's attempt.
No, this is two guys' opinions.
Okay, two guys.
Promise of green technology is often so great that it becomes almost an emotional dream. Yet engineers who are tasked with making dreams a reality often run into reality. This is one of those cases. Anthony Watts, whose climate site has covered the issue, told Fox News. We modeled our most optimistic assumptions about cost reductions in solar power, wind power, energy storage, and electric vehicles, but it would still result in severe climate change with all of its dire consequences. The authors, let's see here. The authors forget that the solution has many parts. First, using energy more wisely can reduce energy. This is another guy saying this. Renewable resources are very important, but they are intermittent in nature, and conventional generation is what ensures that you will always have power. I've always been saying about this. They always need a nuclear backend.
Well, nuclear backend.
Society needs to fund scientists and engineers to propose and test new ideas, fail quickly, and share what they learn, which is the basis for any entrepreneur. Yeah, that's quotes from the Fox News article, which isn't all that cool.
Fox News.
They selected.
But I mean, so on the front end, you've got to be able to build the material it takes that you have to put into your solar panel. You have to make the construction of that material more carbon friendly.
Right. So this is kind of like, you know how if so you got the Stone Age, then you have the Bronze Age, then you have the Iron Age, and I guess maybe we have the Nuclear Age or Space Age or whatever. But in order to get there, you have to have the previous tools to get there to get to the next stage. And so, yeah, I guess if you build a gigawatt in solar and you use only solar, that gigawatt produced by that solar, to produce more solar, and then use that to produce even more solar, and then use that to produce even more solar. I guess it's kind of exponential in that regard. That's not necessarily what's happening. It's the plants that are being built with these technologies are powering entire cities, not just the plants themselves. And so it's diffused, and so you still have all this other stuff that's being used, and it's you're still basically using conventional electricity generation to produce the solar, I guess. I don't know. It's something to that regard.
We have some states building solar farms. Texas and California. Texas, California. I think Iowa is building. Well, Iowa's plan, I thought, was something like 30% from a solar panel farm, and the rest was nuclear, some combination thereof. But I certainly for the next 20 years or so, until we start building those nuclear power plants, we don't have a better alternative. We don't have that good alternative at this point.
Wave power.
But, well, okay, wave power. Yeah. There are definitely exotic.
This is one way that what I saw.
But the key is how do you scale them up? That's the problem. I mean, you had France tried to build that. Was it a thermal reactor? Thermal energy reactor? I don't know how many $1 billion they put into it, and it's
the Tokamak.
That could be it.
That's a fusion reactor.
Fusion reactor, okay. And
fusion's really the way to go. if you want power generation, you go fusion. Lockheed Martin has a compact fusion reactor they're working on. Mind you that no one actually has a fusion reactor that works or produces more. I mean, there was that one time that they did, but there's nothing that's on the grid right now. That's what I'm saying. It's all in development.
So the question is, how bad will things get? What will the negative impact be over the next 20 to 25 years before we start coming up with the technology to really attack the problem? Isn't China saying that they're not even talking about, they're talking about their carbon dioxide emissions peaking in 2030.
Right, and that's why in the treaty that Obama signed, that's why it's at 2030.
Yeah.
Because they figure by the time 2030 comes around, they'll have started to decline in emissions based on their plans to stop building coal power plants and doing renewables and whatnot. So they have 15 years to get that up and running, which I don't know. That's China. They built the Three Gorges Dam.
They got the resources. I mean, well, they're willing to commit the resources.
They got the manpower. That's all they need.
I mean, that is the one thing about China.
They could use pure manpower to turn the turbines to generate the electricity without having any like hydroelectric or anything. Just have people marching in circles.
Yeah, in the United States, we're talking about the profit motive. Whatever it is, you got to build that model, and you got to show the people with the money that, okay, we can now scale this up. We build this first plant, and then we start making money off this first plant, and then we can go from there. But in China, all you got to do is get the government. The government says we're going to do it. Then, like you say, they'll put 1 billion people into it, doing it.
I think the answer is Walmart. I believe that because I think what's going to happen, I believe that solar is going to get so cheap that somebody in your neighborhood will install a solar farm on their roof, and they'll have a rather large savings, and I'll say, where did you buy it from? And he'll say, from Walmart or whatever store he bought it from. And here, look, it was easy. Let me help you. And this will be a grassroots thing where people will be wanting to save money, and they'll start putting them on the roofs. And you'll see it as you get closer to the equator. It'll be more commonplace. And that's where a lot of the population on the planet is. So that's a good thing.
There's a problem with that. A lot of neighborhoods, at least in the U.S., have like neighborhood charters and whatnot that don't allow solar panels on the roof because they're ugly, and it brings the cost of neighbors' houses down, and they don't want it, and so the neighbors complain, and then it doesn't happen.
I bet people's greed will win out, though. They want the money in their pocket. I think that's what I'm counting on. People
it's the greed that gets them off the roof because they think their house is worth less.
Oh, well, that's true. And you know what? You might be right. So the solar panel developers are the ones that innovate and make them and solve that problem where it becomes a shingle rather than...
Yeah, Sharp makes them.
Yeah.
I don't see them that often, though.
Yeah,
they're slightly shiny shingles is what they look like. I'm not sure they generate as much electricity, but...
I got this link to leasing solar panels, but it doesn't tell me what it costs. You know, all kinds of stuff here about why it's good, but it's not telling me how much it costs to get the thing. The warranty is 25 years. No, let's see. No, not telling me.
When I read that site, it says solar lease disadvantages.
That was an article, yeah. Okay, solar leasing. All right, that wasn't from a company. I picked the wrong link. I don't know, but there's a company that will, where you can rent the panels from them, and they'll do maintenance and things.
That's Elon Musk's company.
Is that $60 a month, maybe?
It depends on the installation.
I mean, I'm one guy living in an apartment, and my electric bill, and I don't use much electricity, and it's going to be like $120 for me.
Wow. Wow, that's expensive.
Think about the people with 3 kids.
That's what my electricity bill is right now, and I'm a single guy living in an apartment.
Jeez.
I have no idea why my electricity is so high. All I can think is I cook a lot. I don't go out to eat, and so the money is going from the food that I would buy fast food to being in my electricity bill. But I still think it's. I have a really high ceiling, so I have to heat and cool a lot of bills.
Uh-oh. I don't know. I think we're going to have to get used to the current environment for the next 20 or 30 years at least. Some people will make it. Some people, I think going the solar panel route will help some people get off the grid. So there'll be benefits for individuals. Whether it's a benefit, you know, for the entire society or not, that's another question. That would be one of the experiments we got to do on Science Island. We got to figure out a way of making our own solar panels. Maybe go into a garbage. Another big part of this equation is conservation. And nobody in America is talking about conservation. We Americans, we don't want to get involved in. We don't want to turn out the lights or anything. We want to put 14 high-power lights up. Although the LEDs, the LEDs, are becoming more popular. When Dale gets back here, we can go on to the last couple of stories. Can we come up with, Patrick, a way of testing terraforming on a place like Mars here on Earth?
Terraforming or terraforming?
Terraforming.
There was Biosphere 2 that they tried to do that, but there was a fatal flaw. And they had to cancel. There's no, not really. Well, I mean, if you had a completely hermetically sealed environment, and then you injected the atmosphere or lack of atmosphere into that environment of said planet, and then you started adding whatever you think would change the atmosphere to make it habitable, then yeah, you could, but having that type of environment on a large enough scale to be able to get enough data to do it is really hard without having like leaks and unknown variables happening and stuff. And like, if you add one thing to the environment and it starts changing the atmosphere, and then you add another thing, then that's a double variable system, and then you add a third thing, and that's a triple variable system, and you can't really account for the other variables as well as having just a single variable. So like you can do like 3 different experiments where each one has a single variable that you add, but as soon as you add that second variable from one of the other experiments, then it just goes all out the window because I mean, you can try and do it like a chemistry experiment and get all your moles right and whatnot, but according to at least one guy I know who says he's worked on the problem, he says it's impossible.
Okay, so the underground option.
Mind you, he's already retired, so he doesn't really care anymore.
Now, the underground option. I mean, we've got those humongous salt mines in Poland and places like that. Certainly big enough we could start trying living in and growing stuff in. So the underground option. And would it be that much? Would it be different living underground in Mars as opposed to living underground on Earth? It's got to be different.
Mars has 1/3 the gravity.
Okay.
So your structures wouldn't have to be as rigid as they are on Earth. But on Earth, if there's a leak in the atmospheric containment, then you have a breathable atmosphere out there. But if you have Mars and there's a leak, then you're kind of screwed.
You know what we have to start talking about? Moving people inland. And how are we going to do that in an organized fashion?
You mean underground?
No. I mean, as the oceans rise, most of our population are near oceans, right?
Yeah.
How do we move people inland as the oceans rise? Because that will be an issue. That's practical.
We can do that.
Can we do it in an organized
We
fashion?
can do that.
But is it economically sustainable? How do you suddenly? Where do you put all of them? Where do you put all of them?
The whole business? I don't know. I mean, you can. I mean, there are vast stretches of open territory. Look at Canada. You can easily have plenty of room to put people in Canada. Plenty of room in Arizona. Well, the only problem is the environment. You know, you put lots of room in desert country, but it's desert country.
Here's the problem, though. All those houses that reside by the ocean are worthless. There's no value.
Yep.
You've basically sapped all the economic power out of those regions.
Yep.
How do they pay? How do they, you know what I mean? Who pays?
The remaining taxpayers.
Well, of which there are very few. You know, when you start to go inland...
well, you know what's going to happen? That guy who has his $1 million home in California, Florida, New York, whatever, he's going to go into Iowa. And he's going to buy himself a whole bunch of land in Iowa. And so the land inland is going to be owned by all the people who live around. I've got all the money and live around the coast.
Ed, have you ever seen Superman?
Ah, yes, I didn't think about that.
But yeah, I agree with Dale. I would never buy a house near a river or a lake or a shoreline. Like, it's nice to have like a little makeshift bungalow on the coast, but you don't want to have anything permanent or anything gigantic. Like, there's all these houses that are on these cliffs that weren't on cliffs before, but now they're on cliffs and they're being eaten away. And all of a sudden they're just going to fall into the ocean.
Malibu Beach, California. All the movie stars. Every couple of years, their homes go into the ocean because they have, they have the mudslide. Doesn't stop them. They just go up and build it again.
San Diego has mudslides.
Yeah, San Diego's got earthquake. It's one of the only earthquakes in the United States I've been in was in San Diego.
Well, California has earthquakes. Actually, everywhere has earthquakes. Even Omaha had an earthquake once. It was very, very minor, but...
We've had China rattling earthquake.
Yeah, my dad said he had an earthquake in Omaha when he was like 30 or something. And it rattled dishes a little bit.
That is something that is insane. Well, I remember it was in the Great Lakes, and I think it was Chicago, and they put up very expensive apartment buildings, condominiums, right by, I think it was Lake Michigan or something, not realizing that the lake water, you get some pretty good-sized waves. And the first winter, the water came in and just knocked all those, went into the homes, knocked all the front windows out and everything. Not very good planning. And they should outlaw planning, building housing developments along the Florida coast because they get hurricanes. New Orleans. Should we even rebuild New Orleans? We did. But it's below sea level.
I don't believe in building society below sea level, like Venice. Well, Venice is a little different. Venice, historically, at least they're finding this out, there's I don't know what they call it. Is it a bog that's below the water line? It's like a swamp, but there's no bedrock or anything. They just sink into the mud. And so as the buildings sink into the mud, there's actually a second Venice underneath the current Venice because they built on top of the old buildings. And the old buildings are completely submerged underwater. And they're finding as they're like doing new construction and whatnot that there's these buildings below there that they didn't realize were there before.
That'd be a diver's dream.
Yeah, yeah.
Oh yeah. There are, aren't there tours and things? All these underground cities and.
Yeah, I mean, it's very selective because you gotta be a skilled diver to do it and whatnot.
Yeah.
You can't just do it your first time out. But yeah, there's like aqua cave archaeologists and stuff that go in and do it.
I mean, what's going to happen? Two things. One of the things I've read about last year was salt water beginning to seep into the rice fields in India. And India has the most productive rice fields in the world. It's why they can feed all their people. And for the first time, I think it was in recorded history, they were starting to see some salt water seeping in to those fields. That's a huge problem.
I know they were having issues with GM crops being sold to farmers, and then they lost the crop or whatever, and it's a one-time thing. You can't reuse the seeds, and that's causing a big famine-ish area. I haven't heard about the saltwater thing, though.
What about the Netherlands? You got a whole, most of a country. I don't know if the whole country is under sea level or not, but much of that land, Amsterdam, wouldn't exist if it wasn't for the dikes and things.
Yeah, they just put up like in the last decade, they put up a seawall, and it's a dynamic seawall. They can put it up and take it down as they need to with like tides and whatnot, or it's like a porous seawall. It keeps out the big waves, but boats can still pass through, or something. It's weird. I saw a Discovery Channel thing on it a long time ago, though. So I believe they actually built it. I'm pretty sure they did.
Dale, got a couple of stories left. 3. You can get to them if you want to. You can hopefully read.
Sure.
6, 7, and 8.
Okay, so computers equal to or better than humans at indexing science. In 1997, IBM's Deep Blue computer beat chess wizard Garry Kasparov. This year, a computer system developed at the University of Wisconsin-Madison achieved something far more complex. It equaled or bested scientists at the complex task of extracting data from scientific publications and placing it in a database that catalogs the results of tens of thousands of individual studies. Oh, cool. We demonstrated that the system was no worse than people on all the things we measured, and it was better in some categories. That's pretty exciting. The development described in the current issue of PLOS ONE marks a milestone in the quest to rapidly and precisely summarize, collate, and index the vast output of scientists around the globe. Chess, however complex, is built on rigid rules. In any given situation, only certain moves are legal. The rules for scientific publication are less exact, and so extracting structured information from publications is a challenge for both humans and machines. Peters and colleagues set up a face-off between Paleo Deep Dive, their new machine reading system, and data that scientists had manually entered into the paleobiology database. The repository, compiled by hundreds of researchers, is the destination for data from paleontology studies funded by the National Science Foundation and other agencies internationally. The knowledge produced by paleontologists is fragmented into hundreds of thousands of publications, yet many research questions require what Peters calls a synthetic approach. For example, how many species were on the planet at any given time? Despite 16 years of effort, the paleobiology database remains incomplete, and a large amount of hard-earned field data remains locked in publications. Was it possible to automate and accelerate the process? Teaming up with Ray, who is now at Stanford University, and UW-Madison computer science professor Myron Livney, the group built on the Deep Dive machine reading system and the HT Condor distributed job management system to create Paleo Deep Dive. We were lucky that Myron Livney brought the high throughput computing capabilities of the UW-Madison campus to bear, says Peters. Getting started required 1 million hours of computer time. Wow. So, much like the people who assembled the paleobiology database, Paleo Deep Dive inhales documents and extracts structured data, such as species names, time periods, and geographic locations. We extracted the same data from the same documents and put it into the exact same structure as the human researchers, allowing us to rigorously evaluate the quality of our system and the humans, Peter says. Many organizations, including IBM and Google, are trying to extract meaning from natural language. But Ray says the thing that is different here is that we decided to pivot and look at the scientific literature where the language is cleaner. So instead of trying to divine the single correct meaning from any body of copy, the tactic was to look at the entire problem of extraction as a probabilistic problem. People had done pieces of that, but not the entire problem end to end. This was the deep dive advance. So Ray imagines a study containing the terms Tyrannosaurus rex and Alberta, Canada. Is Alberta where fossils was found, or was it where it was stored? Did the finder work there? Did the study actually focus on a fossil related to T-Rex? Computers often have trouble deciphering even simple-sounding statements. We take a more relaxed approach. There is some chance that these two are related in this manner, and some chance they are related in that manner. In these large data tasks, Paleo Deep Dive has a major advantage. Information that was manually entered in the paleobiology database by humans cannot be assessed or enhanced without going back to the library and re-examining the documents. Our machine system, on the other hand, can extend and improve results essentially on the fly as new information is added. It can also extract related information that may not have been in the original database, but that is critical to tackling new science questions, and do so on a huge scale. Further advantages can result from improvements in the computer tools. As we get more feedback and data, it will do a better job across the board. There are potentially systematic and wholesale improvements to the quality of all the data. Jacqueline Crinion, Assistant Director of Licensing and Acquisition Services at UW-Madison General Library System, says the volume of downloads of scientific papers from publishers threaten log jams in document delivery. Publishers are not going to complain about usage, but about how hard their system is getting hit. Eventually, the UW team they want to broaden access to 10,000 downloads per week. As text and data mining takes off, Crinion says the library system and publishers will adapt. Elsevier is very interested in this project. They see it as the future, and it might allow them to develop new products and ways to deliver service. The challenge for all of us is to provide specialized services for researchers while continuing to meet the core needs of the vast majority of our customers. The paleobiology database has generated hundreds of studies about the history of life. It's a very good example of the added scientific value provided by synthetic databases, where the whole truly is greater than the sum of its individual data parts. Peters notes that many fields are being challenged to optimize usage of old findings and make streams of new data readily accessible. Paleontology and geology are inseparably linked through the role that fossils have played in characterizing geological sequences. Ultimately, we hope to have the ability to create a computer system that can do almost immediately what many geologists and paleontologists try to do on a smaller scale over a lifetime: read a bunch of papers, arrange a bunch of facts, and relate them to one another in order to address big questions. Sounds like a Watson thing.
Yeah.
I was thinking.
Yeah, understanding human language and categorizing and doing some processing on the results. So I wonder if they're not using the same platforms, because they said IBM, right? Or did they not? No, I don't
remember. I don't remember them saying IBM. They just said IBM and Google are trying to extract meaning from natural language.
Yeah, so yeah, that's very much a Watson type thing. The AIs are coming, and they're going to do a much better job than thousands of humans looking at this thing.
Think of all the information that's not easily accessible. All the experiments that have been done, and they're stored on pieces of paper. And somebody did something out in China, and their experiment didn't work. Well, if you knew that, you would try something different. And when we get that, like you say, the supercomputer in the cloud, man, that's going to be a revolution. And this kind of thing is the first step.
Well, it's coming. They're doing it, and they're doing it successfully in many different fields. So, yeah, what's going to happen is people won't realize what's going on in the back end, that an AI is bringing this information to bear for you. It'll just be, wow, this thing is a lot more accurate. That will kind of be the way forward in the beginning. People will be surprised on how accurate their search results are. And we kind of take it for granted all the time that Google gets better all the time, but there's a lot of work being done in the background to make that happen. So I guess the next one, IOP.org. Physicists create a new kind of pasta to help explain mysterious ring-shaped polymers. That's a very odd title. Two physicists from the University of Warwick have taken to the kitchen to explain the complexities surrounding what they say is one of the last big mysteries in polymer physics. As a way of demonstrating the complicated shapes that ring-shaped polymers can adopt, the researchers have created a brand new type of ring-shaped pasta dubbed abalone, which they have exclusively unveiled in this month's Physics World. With just 2 eggs and 200 grams of plain flour, David Micheletto and Matthew S. Turner have created large loops of pasta that, when cooked and thrown together in a bowl, get hugely tangled up, in much the same way that ring-shaped polymers become massively intertwined with each other. So a video of this showing what it's like to eat this new kind of pasta was taken at the headquarters of Physics World and can be viewed here. Whereas it's easy when faced with a bowl of normal spaghetti to suck or pull a single strand out, it's much harder to extract a single piece of pasta from a pile of abalone which get horribly tangled up. The thing about ring-shaped polymers is that they're very poorly understood. In fact, they're one of the last big mysteries in polymer physics. While any kind of pasta is just a bit of fun, the real work involves carrying out computer simulations of ring-shaped polymers, which have shown that if molecules are long enough, they are likely to get so tangled up that they would appear frozen in place. If this were in real life, and there's some evidence to suggest that it is, then they believe they would have discovered a new state of matter, which they have called a topological glass. An ordinary glass material is fashioned when a viscous liquid is cooled far enough that the molecules eventually stop moving and are frozen in place. They maintain the disordered structure of a liquid, but develop the mechanical properties of a solid. Plastic bottles, for example, are glassy materials that are set into shape when ordinary polymers, the building blocks of plastics, are rapidly cooled. For a topological glass made from ring-shaped polymers, the motion of the individual molecules would slow down not just with temperature, but also with ring length, which these guys believe could inspire novel materials and applications that we cannot yet imagine. What would be nice about a topological glass is that its properties would be governed purely by topology rather than the system-specific chemical details that often control when and how classical glasses form. Physicists love that kind of universal behavior. In fact, obtaining a universal description of glasses has been a central goal in condensed matter physics for several decades. While they wait for the news on whether they've been granted more supercomputer time to push their simulations to the limit and learn more about these mysterious ring-shaped polymers, they can sit back and pass the time by picking apart a bowl of delicious home-cooked abalone. When it comes to eating pasta, the Italians were right all along. You're better off sticking to spaghetti, which you can eat nice and quickly. Make yourself a bowl of abalone, and it's likely to have gone cold by the time you've pulled all the rings apart and struggled your way through to the messy end, they conclude. I like these guys. They did something kind of fun with it. They had some fun with normally a dry subject. And
I couldn't find the video, though.
Yeah.
I clicked the link, but there wasn't anything there.
This isn't a spoof, is it?
Oh, I hope not.
Let's see.
It almost sounds like something they would post on April Fool's Day. It has that kind of feel.
A little bit. We're nowhere near April Fool's, though.
No. No, not at all. Well, you know what? November 20th.
Okay.
All right, so next story, this is the last one. From Rockefeller University. Atomic level view provides new insight in a translation of touch into nerve signal. Whether stubbing a toe or stroking a cat, the sensation of touch starts out as a mechanical force that is then transformed into an electrical signal conveying pain or other sensations. Tiny channels in neurons act as translators by helping to formulate that signal to the brain. However, scientists know little about the fine details of how these channels work. So, new work at Rockefeller University has revealed that one such channel in humans responds to mechanical force using a never-before-seen mechanism. Examine something called the track channel, which is involved in painful touch sensation at the molecular and atomic levels, finding that it works by reducing the flow of potassium ions that create an electrical signal. It is fascinating to wonder how living cells evolved molecules capable of turning small mechanical forces, such as those associated with touch, into electrical signals in the nervous system. That question served as the impetus for this work. The channels that act as gates in the membranes that envelop neurons, including track, allow electrically charged atoms called ions to move in or out. It's this movement that is the basis for an electrical signal that carries information. Track channels are one of 78 types of channels in the human body that transport potassium ions. There are other devoted to other ion types. By allowing potassium to trickle out of the neuron, track normally quiets the neurons, balancing out other channels, which would otherwise create a strong electrical signal for pain. Track acts like kind of like brakes on a painful touch sensation, while other channels act as the gas. If you take away the brakes, innocuous touch becomes painful. Oh, that's kind of cool. Prior work in the lab has shown track responds to membrane tension, that is, stretching caused by a physical force. However, it wasn't clear how this force caused this channel to open. In fact, scientists previously only explained the workings of two mechanical force sensing channels, both of which are found in bacteria. After purifying the protein that makes up track, the team crystallized it and determined the structure using X-ray diffraction analysis. Based on the pattern produced by X-rays bounced off the crystallized protein, scientists can infer the structure of the molecule. But because it is difficult to get high-quality crystals from track, the researchers used antibodies that targeted and create a sort of scaffold to help guide the formation of the crystal. In the structural images revealed by this work, the researchers found a unique system is responsible for holding off the flow of ions. Track's central cavity, through which the ions must pass, is flanked by two spiral-shaped chains called helices. When both of these channels are kinked upward, the channels open so potassium can leave the cell. But when one of these two chains relaxes downward, it uncovers a sort of side door into the center of the neuron membrane. Neuron membranes, like all membranes, consist of two layers of molecules called lipids that have heads facing outward and greasy chains extending inward. When track's side door is open, one of those greasy chains, called an acyl chain, hooks into track's central cavity, blocking it so no potassium can pass. No known channel uses a mechanism like this. It's the first time anyone has seen at a molecular level how mechanical force can open a channel in animals, including humans. When the membrane stretches, track widens, sort of like a dot on a balloon that expands as it is inflated. That wider conformation pulls the helices upward, preventing the acyl chain from blocking the channel, and so leaving it open for potassium ions. The direct involvement of lipid molecules in the gating mechanism begins to explain other well-known property of track channels, that their gating is sensitive to general anesthetics and other molecules known to enter the lipid membranes, where they insert themselves between the acyl chains. By doing so, it appears that these anesthetics can shut down pain sensations by locking track in an open position. Cool. That's pretty neat science. So again, every time I read something that they make a breakthrough on something, we sound more robotic as we go. You know, basically that's you're modulating an ion channel with mechanical force.
A pain blocking mechanism.
Yeah. So potassium ions, when it becomes distended, they're redirected into the neuron and creates a response, which is, you know, it's almost like how you build everything from simple mechanical devices that we use to transistors and electronics with you know, NPN junctions that are biased by an outside current. That's really kind of a similar principle. You know, and it's not surprising either, because we're just a part of nature, and all the things that we've built, you know, the crude things that we've built, it's nature, and we're a part of that nature. So why would it be unusual to think that somehow our organic chemistry would be any different than the other natural environment that's already out there?
You know, learning how the process works at the molecular level, the chemistry involved. Everything is chemistry.
Yeah, and chemistry gets into robotics, really. We don't think of it that way, but it is. It definitely.
Chemistry into robotics.
But
Programming, I agree with you there. Well, everything that happens in the universe is chemistry, so at the fundamental level, yes, you're correct. I can see that.
If you watch a ribosome process and translate RNA into a peptide chain, if you watch that,
I saw that in a video. It was very, very cool. The little chug, looked like a little factory.
they're factories, yeah, and it's very robotic. We don't like to think of ourselves that way, but you know, at the molecular level, you know, beneath the wavelength of light, that's what we are, and I think that's amazing.
It's amazing, and I'm getting back to that YouTube, just on YouTube, where you can actually watch the the interactions, the DNA folded around the histone, I guess it is.
Histones, yeah.
And you see a little, you know, it's going into the I forget the other, the messenger RNA and the RNA itself.
Yeah, messenger RNA is where the code, that's the ticker tape, and the transfer RNA carries the amino acid, and it locks in to whatever the message RNA is asking it to do, and it brings the next peptide in the polypeptide sequence. It's bringing the next one to bear, and building a protein. Like it's so mechanical.
It really helps when you can see it, as I say, actually see it happening.
Yeah, once you get rid of all this language and you see an animation, a lot of people go, oh.
That's exactly right. Let's get rid of books.
Yeah, like the language is hard to get your head around, but when
animation.
You watch...
I know Jani loves animation, so let's make everything animation. It would be a much better learning process. It makes for a much better learning process. And then, of course, you got to do it yourself.
You know, I wish they had a simple way of describing biology, but they had to use some words, you know, to describe everything, and unfortunately, it's like a new language.
Well, it depends on the level you want to understand it at.
I guess, yeah. But
I mean, I can read these stories and make some sense, but you show me the abstract, and I don't know what they're talking about.
That's why it's the abstract.
Yeah, that's right. They don't understand either. Yeah. No, that was really good. I like that last article. It's interesting. They're in a new area that no one's really touched upon, doing the hard science.
You got to get that supercomputer in the cloud where everything is stored. Giving people access. All these researchers, how many mistakes are repeated by a researcher who doesn't realize that this exact same thing was tried before?
Yeah, I think that's a real problem.
And I think that I think it was in Nature.com where they talked about the number where people don't publish papers where their experiment fails. That's important. It's important to know that this particular experiment failed, so you don't do it again. And there's just large numbers of failed experiments, and you just don't get published. Nobody knows about them.
Yeah, there's a real push on to get that stuff published. Are we going to call her a night there?
That's what I'm looking at. We're approaching 2 o'clock. We've been around almost 2 hours. That went pretty quick. No. Probably have another Thursday night hangout about the same time next week. As I've posted in the different Facebook groups, if anybody wants to have a hangout at another date, earlier, I know Byron Condren sometimes, I know Pamela Sue Taylor Gray is now in Europe. She was in CERN. She was actually visiting CERN today.
Cool.
Yeah.
Maybe we'll have some more hangouts at an earlier date. In any event, I will stop the broadcast and hopefully see everyone next week.